what are we doing today? Well, I've got a plan. Now, in my house, I run a 12-volt system, and in a cupboard next to the batteries, there is a 100 megabit network switch that is running off 12 volts with a little regulator that brings it down to something like 9 volts. Is what the switch needs. Now, that is currently a bottleneck in my network, as is another one somewhere else out in the shed. So I'm seeking to eliminate that bottleneck. So I've got myself a TP-Link, a 5-port Gigabit network switch. Now this guy comes with a plug back that supplies 5 volts, which is very easy to do. And I've got a bunch of different 5-volt regulators kicking around. Oh, and it's got LRFs with it too, little rubber feet. So what I'm going to do is looking at converting this. Now the previous one I just put a little screw hole on the back here and mounted an LM7809 to the back. We can get a 7805 chip to do this, but I wonder if I can modify it internally to take 12 volts and put the regulator on the inside. So I might pop this little guy open and see what's inside. Alright, we've got the cap off here. Now, my initial plans of thought I had of maybe diverting the tracks on the back of this are probably not going to happen. But there's this huge big area out here, and there's already a factory hole in here. I'm thinking I might put an inline socket for 12 volts. I might put a bridge rectifier and a linear regulator in here. And at 0.6 amps, I think we're going to get away with probably using one of the little mini regulators I've got. And this is actually a nice little heatsink in here too. I'm quite impressed. And these look to be proper isolated network switches, or network connections as well. That's good. I think they might be opto isolators, I'm not sure. But I do like these little TP-Link ones with a proper metal case. So, yeah, let's go and find ourselves a regulator. Alright, so we're hiding away in the cupboard down here, and we can see our existing one. And I want to find out what we've got going here. We do have a plug already. Cool. That's one of those 5.5 2.1 plugs. I can definitely use that. I don't need to change any wiring. So let's go back and select our appropriate hardware. So given that the existing switch that I'd forgotten about has a 5.5 2.1 plug, that'll be nice. And it does mean that if some retard tries to plug in that plug into the wrong hole, it's not going to work. So I might put a pigtail out and an inline socket on this one, and that'll make installation very easy. So and then I'll have a spare 5-volt plug pack to use for stuff. Now we need to find a bridge rectifier and regulator. We may have to make a bridge rectifier, but that's fine. Let's scrounge through my parts for that. Alright, we've got a selection of parts here, and we've got a few options. Now, I do have a bigger stack of diodes and prototype board, so I could have easily made a smaller, more compact bridge rectifier using 4 diodes, but these guys, I've got a bunch of them, so I thought I'm just going to use that and be lazy. That should also drop the voltage by about 1 volt, which is nice when you're feeding into a regulator. It just makes the regulator run a little easier. Now, we know about that, and we can get this out of the way as well. Here's our 2 options here. This is an LM7805. I'm not sure if we can see from the lighting here, the labeling on the front of the chip. It's a very indistinct and very faint laser engraving. But that's an LM7805. That's a positive 5-volt regulator. It's volts in, ground, and volts out. Very nice. They do get very hot, and they're a linear regulator. So they do it basically by variable resistance. They just get hot and waste the excess current as heat. Not very efficient. They're good for about a 0.5 amp normally. This little critter here cost me about 1/3 of what that does, and this is good for about 0.8 of an amp, and they run very cool, and they're a switching regulator, although it looks very much like a linear regulator on here as well. So I could be wrong about that. In either case, these run quite cool from my experience. They have a little indicator LED, and it's volts in, volts out. Everything's nicely arranged. I think I'm going to use one of these fed off the end of that and pack it all in that nice little spare space. I think that'll be the easier way to go. And the reason I put a bridge rectifier in here is I can't accidentally get the polarity wrong. I think one of these should be in nearly all DC electronics to make sure things don't go wrong. And because I've had so much stuff that's been given to me that's been fed the wrong voltage or the wrong polarity and from plug packs and has blown up. With this scenario, you can't get it wrong, and the range of voltage you can plug in is very wide. So these two little components, your stuff's going to last a long time. All right, let's wire these up. All right, I've got our famous blob of blue tack here, and we've got some wire here, which I think is 0.12 mil. Should be plenty enough for the task. I'm going to tin the ends of this wire. I'm going to attach to our voltage outside. It looks like my magnetic tip is a bit stuck here. We're going to use our noisy outlet fan as well. And I need to get a bit of solder on here. Alright, let's try and tin this cable. Iron might be a smidgen on the cool side too. Might as well tin both ends of this wire whilst I have the chance. And we will insert this into the board and go from there. Now I am finding that whilst I feel it could be a bit boring watching me solder all these things and ramble along in the video, finding the videos where I do exactly what I'm doing now seem to be the more popular ones. So not that I'm aiming for popular or profit, although somebody did actually sign up for my Patreon just the other day, and over the Amiga destruction video, that's the only place where I've actually posted a link to that. So somebody actually was happy enough to sign up. So he's a nice bloke, and I'd sort of geared that whole Patreon page towards the trolls having to pay if they wanted to find out that it was a bit of a hoax, or actually an April Fool's Day joke. It was posted on April Fool's with a bit of creative editing so that the date didn't show up as April Fool's. And the intended target did end up being a little bit flustered by it, much the same as I was by his negative comments. But yeah, so now we've got our regulator here. But yeah, I digress about the Patreon thing. Yeah, I'm not looking to make money out of this. By no means am I looking to make money. But if you want to find that Patreon and you want to find that Amiga destruction video and sign up, well, you're quite welcome to. I'm not going to complain. Now, let's see what we've got here. We have our ground wire, which is conveniently red. That is going to go onto our negative output of our regulator here, which of our bridge rectifier. Now that needs to be shortened slightly to ensure a good connection. We will go like so, which leaves only one other option onto the positive outlet here. Alright, that's good. And we want to make sure that that is definitely volts in on that side there. Yes, that is volts in there. Sorry, I'm not looking through the viewfinder, so I do tend to lose track of where I'm pointing. Alright, that's good. This cable is actually not too bad. I might use that for the outlet. Alright, so I'm going to rinse and repeat here. I'm going to do two more little bits of wire about this length, tin them up and solder them in. So we'll be back as soon as I do that. So I've skipped a couple more steps forward. We've got our both sides wired here, and I've got a negative wire marked just so I don't have any mishaps. We've got our power socket here that's going in, and a little bit of heat shrink. And from here we're going to thread this through our shroud, and this will be our pigtail. So there we go, that's our pigtail. I'm going to, now that I've got this wired up, I'm going to chop both of these to an even length, like so. And I'm going to strip these and solder them onto the rectifier. So let's do that just real quick here. Okay, so I've taken the step to thread these cables through that hole in the switch up here already, just simply because stuff's not going to fit once this is soldered on. Now, polarity here doesn't make a lot of difference, because either way things go through the bridge rectifier, the polarity is going to be right. So we're going to get this in here. We're going to go in through that, just reheat them a little bit because they're thick pins. That should be good. Normally I would heat shrink them, but the chance of these pins bending is minimal. So this should fit nicely into this little cavity in here. I'm going to glue these down a little bit, and I might put some heat shrink over this, because that way I can stick it down without it shorting to anything. It should be pretty good. Bridge rectifiers do get a little warm, but we can stick that up on the side of the case. That'll be good. What I do need to do now, before I do any of that, is undo these 3 screws, pull this board out. I'm going to solder the supply wires directly in underneath that power socket onto the pads on the board. So let's get the main board out. Okay, we've cut to the back of the plug pack here for an important reason. This little diagram here, which I'm not sure if we can focus close enough, but this indicates that the center pin on this is positive. At least if I'm reading that correctly, and that the outer is negative. So what we can do now that we have the board out is we can observe the socket here, and that this pin here is the center pin, and that is the rearmost connection. So if we flip over, we know that that connection, if we flip over the board, we know that connection there is negative, and that one is our positive. I'm even going to mark that just for that purpose. Jump off camera slightly here for a moment. I'm going to mark U as neg and U as pos, just so I don't get them backwards when I'm hooking the wires up. So let's put this down on the blue tack and solder onto it. Now, a little catch here, most of this stuff, if it's intended for sale in the UK, it's probably got lead-free solder on it. So we're going to put a little bit of 60-40 tin lead in here and just reflow those joins. Now, my eyesight's a little dicky because of multiple sclerosis, so we need to find my nice contrasting black striped wire. Now that is our negative wire, and that is ground, yes. Now before I do this, I need to put some heat shrink over here. I almost forgot that. Okay, so I prepped a bit of heat shrink. I've elected to go with some translucent stuff, largely because that LED has, largely because the board has an LED on it. And yes, I'm tired, and my language is, and terminology is going with it. Oh. Here's Mr. Stoner Torch Green today. There we go. Right, that should work. That's shrunk in nicely. And a little bit on the back. Right, I'll let that cool off for a minute, but we should be able to see the light illuminate through that. I'm trying really hard to enunciate. Anyway, whilst that's cooling, we'll take our stripy wire here, which is indeed negative. We're going to triple check. Yes, that is our ground. So let's drop onto this socket that we just soldered onto. And I'm also, you'll notice I'm facing this side just to keep the cables heading out in a nice, easy to manage direction. Alright, there we go. Now this means I can use the factory supplier to supply this, or I can use this as well, and I think there is a diode in here as well. But this should be handy. Let's get all this assembled back in the case. Have a bit more of a chat whilst I put all this back in the case. And I notice we've got some tape there already. That shouldn't be a huge issue for these components. This is going to drop back in nicely. Just want to make sure we're not going to have a short circuit event. I think I've kept that wire at a fairly consistent height with the pins, so I don't think that's going to be an issue. We will find out when we plug it in and it lets its magic smoke out. Crucially though, that little regulator will go pop long before the cable does, which is probably a good indication that you don't need a fuse. I've got this socket misaligned in the back. I knew I was going to do something silly like that. Pull that screw all the way out. And sometimes filming stuff is actually less enjoyable than actually doing it without it, because I've sort of really got to focus heavily on what I'm doing in two locations. And one of the side effects of multiple sclerosis, and more to the point, the brain lesions that come with it, is that multitasking is not much of an option for me anymore. So yeah, sometimes when I've got to film this stuff, I get dodgy camera angles, but I don't know, you guys seem to enjoy the amateurish nature of my stuff. So let's get in here a bit. Aha, nice little divot in here. It's been very kindly placed in here for a screwdriver, which I appreciate. Don't appreciate Phillips screws, but that's another rant for another day. Alright, we're in like Flynn, as EED blog says. And that little chip, I think actually the tension of the cable might even keep that in a comfortable position. This guy, I might use some of the hot glue that made all the Amiga guys nuts. I might just put a little bit in there just to stop it bouncing around. Where do we have it? I'll get Mr. Stoner Torch Green back on the job and we'll put a blob of that in there. Okay. And yes, for the record, I don't like hot glue guns. The PTC heaters in them, they keep dying at an alarming rate. So my confidence in them is pretty low. Alright, let's put our regulator, our bridge rectifier right in the corner there. Alright, that's good. In fact, I probably don't need to do much more than that. I think we're pretty good. I'm not even going to try and neaten them up. I'm not going to mess with it if it ain't broken right now. So I'm going to do a quick pack up of my tools and then we're going to test this. Alright, the time has come for smoke test. I'm going to take my test lead and we're going to fly up over here to my supply board. We're going to plug this in. Polarity not important. That's a rarity. So we'll drop back down here on the other end of this lead. So 5.5, 2.1. And we will stick this down with a blob of blue tack. Alright, let's go and turn our switch on and see what happens. Right, we had a, oh, there's a short circuit somewhere. Something was flashing. I had a bit of an overloaded circuit, so let me unplug and see what's happening. Okay, so interesting development. I had to pull it all apart again and have a think about what was going on. So let's actually get our test lead and demonstrate what I have discovered so far. So we've worked out that nothing was wrong with what I did, that it all works fine. Our red light comes on, we get 5 volts at the end here. I'm going to check the polarity. I'm thinking maybe it's a reverse polarity protection here, and maybe I got that bit wrong, which means I could have cooked it and there was a funny smell coming out of it. So I'm going to trace back from some circuits here and I'm going to get the original plug out and get a multimeter and try that. Alright, so I have original power supply plugged in. Let's have a look here and see what we've got. I'll plug you in like that. So the switch appears to work. That's a good sign. Okay, let's take our multimeter here. We'll take negative on the outer shield and we'll go positive in here. We're seeing a positive voltage of 4.9 volts. And just for the comparison's sake, we will reverse the polarity and put the negative terminal in the middle and it shows a negative voltage. So we do know that it is definitely center positive and we know that the switch works. So we've got to figure out why that's not working. So the way I'm going to do that, I'm going to plug switch in. I'm going to take this blob of blue tack here and stick it down so the cable doesn't drag it off the bench. and we will change our camera angle slightly. I'm going to test that I have the polarity correct here. So what do we have here? Well, we have volts there, but we don't have volts here. Okay, we have minus 4.9 volts, so that is actually backwards. So the one assumption I made was wrong, very wrong. I'm glad I didn't fire that up for too long. Alright, so let's see here. So that is actually plus, and that is negative. So guys, lesson learnt. The one day you go, she'll be right, is the day where things don't work out right. So let's resolder our wires back in the correct position here. So that is going to be negative. And we want outlet fan. Tip a bit of a clean. We'll flow that one back into here. Alright. This one is going to be positive. Yes, that does have our stripes on it. So let's do U in here. Okay. Thankfully, not too much of a fault finding process. So let's reassemble this and smoke test it a second time. We almost actually had a smoke test on camera where it smoked. Not something I really aspire to, but we'll see how we go. Okay, let's try this properly this time. I think I've got it right. Okay, red light is good, and green light on the front is also good. We have ourselves a 12 volt network switch that will also deal with low voltage events. That'll be good. It means if I have a bit of a short circuit at this end of the line, I won't kick my financial manager off the internet down the other end. Okay, let's get the cap on. You guys didn't get the benefit of seeing this come apart. It has two little lugs under here that are very nicely done. This is actually a very smick case and smick design. I like it a lot. And this is how I'm used to. I kind of grew up with hardware like this. I much love a metal case over a plastic one. And they've even got to the trouble that plastic sheet on the inside actually will flex in a bit where these screw holes are, so that your screws don't accidentally short across the bottom of the board as well. Really nice. Alright, I haven't bothered putting some strain relief in here because I know where this is going, but if this was something I was handing over to someone else, I would certainly invest in some strain relief. Let's turn off that noisy fan, get my tools packed up, and we'll go install this. Alright, well, that's another bottleneck on my network removed. however many midnight mistakes I make. Now, I went back over my footage before editing here, and I saw what I did, getting that polarity backwards. I correctly identified the terminal for the center pin as positive, flipped the board over, pointed at it and said, yeah, that's positive, and then drew a negative next to it. A little bit of a brain fart there. But that does happen. It's something like 1 a.m. right now. So some of these things I've got to do whilst the World of Warcraft players are off my network, so that I don't get yelled at. It does come with the drawbacks of having a bit of sleeplessness and a bit of slurred speech, and some hot glue stuck to my bench. So yeah, I think I'm going to go and get some sleep, and I'll see you all in the next video. Hopefully I don't smoke things up. Well, I didn't this time, but I come close. Anyway, see you all in the next one.